Last little bit of stuff we're going to do is some stuff on matrices and then Kramers Rule. I don't really do a whole lot on matrices because unless you're going to be a computer programmer, I don't know where you're going to use them much. But you get the general idea. So the first ones here is scalar multiplication of a matrix. And they said let E be the matrix -3, 6, -4, 5, which is a 2 by 2 matrix, 2 rows and 2 columns. If I'm going to find -4E, it's just like you probably think. I'm going to multiply -4 times E. When I do that, I'm just taking each of my values times -4. So -3 times -4 is 12. 6 times -4 is -24. -4 times -4 is +16. And 5 times -4 is -20. And that's just going to end up being my answer. Number 2, you have a 3 by 2 matrix, 3 rows and 2 columns. I'm losing my mind. So when you multiply, you're going to end up with the exact same size matrix as you started with. The size isn't going to change. I'm just going to multiply everything by 3, and so I'm going to get
6. -5. 18. 3. -15. 0.
and there'd be my answer. And number 3. This one has 2 rows and 3 columns, so it's a 2 by 3 matrix. And I'm going to multiply everything by -2, so my first row I'm going to get
-14. 12. 0. -10. 4. -2.
and that'd be my answer. Easy enough, right? Next ones we're doing addition and subtraction of matrices. In order to add and subtract matrices, they have to be of the same size. You can't add a 2 by 3 matrix with a 3 by 2 matrix. And so when you're doing your adding or subtracting, all you're really doing is adding the values that are in the exact same spots. So my matrix will end up being the same size it originally was. I'm going to take -7 plus 7, which is 0 for my first number. 3 plus -7, which would be -4. 0 plus 6, which would be 6. And -2 minus 1, -3. And that's going to be my answer for A plus C then. When I'm subtracting my matrix, it's like I have to use the distributive property. So I'm subtracting the D matrix. I'm going to change all of my signs in there. And so this is going to be +5, -7, -4, +7, 0, and -5. And then I can go ahead and just add the ones in the like spots, right? Yeah, that almost was right. 4 plus 5 gives me 9. 7 minus 7 would give me 0. 7 minus 4 would give me 3. 6 minus 7, what am I doing? 6 plus 7 is 13. 1 plus 0 is 1. -5 minus 5, -10. So just like when you subtract with a polynomial, you have to distribute your negative and change all your signs, and then you add. And so on number 6, I'm going to do A minus D. So first of all, if I change my signs on D, I'm going to get -2, -3, +7, and -2. And so then when I add my two matrices together, I'm going to get
1, -8, 8.
1, negative 8, 8, and negative 4.
Okay.
7, 8, and 9, now they're going to throw the multiplying sort of in with the adding and subtracting, but here I just distribute that negative when I multiply, and so I multiply first and then always add my two answers together. So I'm going to take my first matrix times 4, so negative 12, 20, 16, 28, 28, and 24. I'm going to take my second matrix and multiply it by the negative 6. So negative 42, negative 36, negative 6, positive 42, negative 12, and negative 18. So once I've multiplied the first one by 4, the second one by negative 6, then I'm going to add the ones that are in the like spots. So negative 12 plus negative 42 would be negative 54. 20 plus negative 36 would be negative 16. 16 minus 6 is positive 10. 28 plus 42 must be about 70. 28 minus 12 would be 16. And 24 minus 18 would be 6. So on number 8. If we take d times negative 5, we would have
Negative 25, 35, 30, negative 5.
and we are going to take e times 4. So we would get
Negative 24, 24, 8, 0.
and then we're going to add those two matrices together, so our answer is going to be
Negative 49, negative 11, 38, negative 5.
exactly. And number 9. First we're going to take f times 4. So my new matrix would be
20, negative 12, 0, 0, 4, 8.
and then we're going to take c times negative 6.
Negative 42, negative 6, negative 12, negative 42, negative 30.
And then we're going to add the ones in the same spots, so we're going to get 50, negative 54, negative 6, negative 12,
Negative 38,
negative 38,
negative 22.
and negative 22. Easy enough, right? Next thing we're going to do is find the determinant of a 2 by 2 matrix. And they tell you to find the determinant, you're going to subtract your cross products, but you have to go in a certain order. You're always going to start here in the upper corner, and you're going to multiply it times the bottom corner on the right, and then you're going to take the -6 times the 3. So I'm going to do the 4 times the 3, which is 12. I'm going to subtract the -6 times the 3, which is a -18. Since I'm subtracting a negative, I end up adding, and so the value of my determinant is 30. So on number 11, 3 times 6 is 18. I'm going to subtract -4 times -4, 16. So my answer is 2. Number 12, we're going to have -15. We're going to subtract -9. So -15 minus the -9 would give me, try that again, -6. And the reason that we had to figure out how to evaluate a determinant is because we're going to use it for something called Kramers Rule. Kramers Rule is another method, because we didn't have enough methods to solve systems of equations. I actually had one person when I used to use a textbook, she never used substitution, addition, graphing, always used Kramers Rule. She loved Kramers Rule. On Kramers Rule, what you're going to do is set up the determinant D by using the coefficients of your x's and your y's. So I'm going to have 7, -6 in my first column, 7 and 4 in my y column. I'm then going to find the value of that determinant like we found them on the previous problems. So 7 times 4, okay, now I decide not to write on me. There we go. Is 28. I'm going to subtract -6 times 7, which is -42. So I have to take 28 plus 42, which gives me 7. Now, x is equal to what they call d of x divided by d. You notice that they just put d down here on the bottom. I'm just going to put 70 down there on the bottom because I'm going to have a 70 down there and I don't want to forget it. I'm then going to find the d sub x determinant. I find that by replacing the x column with the answers over here, and so the 8 and the 7 go in the x column. The y column stays the same, 7 and 4. I then find the value of that determinant. So 8 times 4 is 32, 7 times 7 is 49, and if I subtract, I get -17. So the value of x is going to be -17/70. For y, we're going to replace the y column with the answers over here. So the 8 and the 7 go in the y column. The x column stays as it originally was, so 7 and -6. And then we find the value of that determinant. So 7 times 7 is 49. We're going to subtract -6 times 8. 6 times 8 is 48. And so on that one, we end up adding 97 70ths. So for fun, we're going to check our answer just to see if it works out right. Grab your calculator. We're going to take 7 times -17/70 plus 7 times 97/70 to see if we actually get an 8 or not. Yes, we do. Okay, good. Then we know our answer's right. We could check it in the second equation if we really wanted to. But it should give you a pretty good idea if you got the right answer or not. So, number 14, we're going to use Kramers Rule. And on Alex, they are going to make you fill in all these boxes to be sure that you really are using Kramers Rule to solve the problem. So, my first determinant D My first column is going to be
1 and 1.
You're looking at 15, I think.
15.
Are you looking at 14? 5 and 5. And my second column is going to be 3 and negative 2. So we need to find that value of that determinant. We would do
5 times negative 2.
so negative 10
Minus 5 times 3.
minus 15. So I get negative 25, right? So I'm just going to go ahead and put my negative 25 down there so I don't forget to put it on my answer, hopefully. So now I need to do my determinant. It's called d sub x. I'm replacing my x column with my n numbers. So my first column is going to be negative 3, 1, and my second column would be
3 negative 2.
the 3, negative 2, because it's the y's of the original problem. So finding the value of that determinant. We would get
3.
3, because we have 6 minus 3, which is 3. So negative 3/25 should be our value for x. Our y determinant, we're going to have what? 5 and 5, and whoops, yeah, 5 and 5, and then our y column is
Negative 3 and 1.
negative 3 and 1. So finding the value of that determinant,
20.
20, 5 plus 15 is 20, so 20 over negative 25, which of course we're going to simplify, and so we're going to have
4 over negative 5.
or negative 4/5. Since we usually like the negative out in front, right? And again, just to quickly check that on your calculator, take 5 times negative 3/25 plus 3 times negative 4/5. Vada's checking this one. He's leaving it up to you. And we get negative 3, right? And that's what we're supposed to get. Negative 3. So we must have did it right. It's always good to check. And the last one of the whole summer. My d determinant would be what?
3 and
1,
1.
1,
4 negative 2.
and 4, negative 2. So the value of that determinant would be
Negative 6.
negative 6. Negative 2 minus 4 is negative 6. So, put my negative 6 down there so we don't forget, and then I'll do my d sub x determinant. So that one would have
Negative 9, negative 6.
9 and negative 6,
4 negative 2.
4 and negative 2. So,
Negative 6.
we got negative 6. So we got negative 6 over negative 6. Hey, that gives us 1. And d sub y, our determinant for that one would be, wait a minute here. Let's check your work. Negative 9 times negative 2 is 18, right? Then I have to subtract negative 6 times negative 4, which is a minus 24. If I'm subtracting a negative, I probably better add. Veda didn't yell at me, but 18 plus 24. Must be 42, huh? So 42 over negative 6 would be negative 7. That what you got?
Yeah.
She says sure. All right, let's check y. What's my determinant on y?
3.
I didn't even put the numbers in yet. So 1, 1, negative 9, and negative 6. So I'm going to have negative 6 plus 9, which is 3. 3 over negative 6. Y must be negative 1/2 then, huh? Let's check that one quick. We're going to have x is negative 7 plus 4 times was it negative 1/2? Yep, negative 1/2. Well, that's easy enough to do without my calculator. Yep, negative 7 minus 2 is negative 9. Looks like it checks pretty good. All right. Probably not anything that you've never done before, I'm guessing.